and welcome to my YouTube channel, where every episode I take a physics topic and hopefully explain it in a really simple and understandable way. Now, some episodes are just going to be fun physics facts, but most I'm going to try and tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. Today's episode is the long-awaited sequel from one of the first 5 episodes I released on speed, distance and time. I mean, I don't think anyone knew there was going to be a part 2, like not even me, but here we are. I just have so much more to tell you about speed, which requires a new episode on it. Is that okay? Well, let's crack on with it then. I'm going to start by talking to you about distance time graphs. Let's run you through some of the key rules for these graphs. So you put distance on the y-axis and time on the x-axis. And make sure you label those axes appropriately. So the y-axis, which is the vertical line, should be labelled distance brackets m, or whichever unit you want to use for distance. And then the x-axis, which is the horizontal line, should be labelled time brackets s, or again, whichever unit you want to use for time. What this graph shows is the distance travelled by an object over a certain amount of time. The gradient of the line on the graph, so that's the slope or the angle of the line on the graph, will tell us the speed of the object. That's cool. Here are some tips on how to tell what the speed is doing just by having a quick look at the graph. So the steeper the line is, the faster the object is moving. That's steep. And vice versa, so the flatter the line, the slower the object is moving. That's slow. All the way down to if the line is dead flat and horizontal. That means that the object has stopped moving altogether. So flat means stopped. If the axis states distance from the start, then this means that any downhill sections, so any sections where the line is sloping down and reading smaller distance values, this means that the object is moving back towards the starting point. And lastly, if the line isn't straight, so if it's curved at all, then this means that the object is not travelling at a constant speed. Its speed must be changing. Just like when the lines are straight, if the curve is steepening, then this means that the object is speeding up and therefore accelerating. And if the curve is dropping off, then that means that the object is slowing down and therefore decelerating. Cool, so that's the basics you need to know about distance time graphs. And remember, if you read between the lines, you can work out what the speed of the object is. And now I'm going to answer the question which I know you all want to ask, which is, what is relative motion? Well, isn't today just your lucky day? Relative motion is the speed of 2 moving objects. So if you're moving and another object is moving and you want to know the speed of that object, then relative motion comes into play. Right, so an easy example is if you're out for a little cycle ride and you're just chilling, cycling along, and then another cyclist overtakes you. Rude. Anyways, if I was cycling at 8 miles an hour and then a basically professional cyclist overtook me at 15 miles per hour, then their speed relative to mine would be 7 miles per hour. Because that would be the difference between our 2 speeds. Therefore, this keen bean would cycle past me as quick as if I was stationary and they cycled past at 7 miles per hour. So that's example 1. 2 cyclists travelling in the same direction. You find the difference between them and therefore subtract their speeds from each other to get their relative motion. But what do we do when 2 objects are moving in the opposite direction, towards each other? Right, let's make this a little bit more exciting. Imagine you're on the plains of Africa. What do we see in the distance? It's 2 cheetahs sprinting along the same line, directly towards each other. So to calculate these two cheetahs' relative motions, you add them together. Makes sense. It's the opposite of what we did when the cyclists were moving in the same direction. So we have cheetah approaching from the left, let's call him Spots, and then cheetah approaching from the right, let's call him Blobs. Spots is travelling at 97 kilometers an hour and Blobs is running at an incredible 123 kilometers an hour. And both of them are running towards each other from opposite directions. But Blobs is moving towards Spots way faster than if Spots was just standing still. And that's because Spots is also moving towards Blobs at a given speed. So to work out the speed of Blobs relative to Spots, we add their speeds together, which means 97 kilometers an hour plus 123 kilometers an hour, giving 220 kilometers an hour. So the speed of Blobs relative to Spots is a whopping 220 kilometers an hour. Whoa! Thank you for listening. I hope you enjoyed it. If you did and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I'll try to do a video for you.